PRF is fabricated chairside with the Intraspin system by Intralock International, the only medical device that is FDA cleared for the production of PRF. It is a simple three-step procedure. We draw blood, we spin the blood, and then we express the fibrin clots. Within the Intraspin system, there is a blood collection material set, selected for biocompatibility and maintenance of the blood sample. Next is the centrifuge, a medical-grade device specifically engineered with a set of parameters that will give us proper consistencies of PRF. But not all centrifuges are capable of producing the same quality PRF. In this study, done by Dr. Nelson Pinto of Concepcion, Chile, they examined several commercially available centrifuges and then did a scanning electron microscope study of the quality of the fibrin that was produced. This particular centrifuge, produced in China, produced a poor quality fibrin mesh and had damaged cells. The centrifuge in the Intraspin system showed a high quality fibrin mesh and virtually no damage to the cells within the fibrin clot. This is important because biologic efficacy is directly related to the number of vital cells. Finally, the heart of the Intraspin system is the expression box and the instrumentation kit. This is designed to optimize the final step in the fabrication of PRF. As you can see, the compression plate in this box guarantees that you will end up with membranes of a consistent thickness. The first step is to draw blood. The needle set enters at a 15 to 30 degree angle, and then blood collection tubes are used to harvest whole blood from the patient. We do this in even numbers before they are placed in the centrifuge. The tubes are now delivered in a balanced fashion. We close the lid and we spin for 12 minutes at 2700 RPM for the normal patient, or at 18 minutes at 2700 RPM for the anticoagulated patient. The third step is to express the clot. Here we demonstrate the retrieval of the fibrin portion and then the removal of the red blood cell fragment. We exclude the red blood cells because there's no biologic activity. The fibrin clots are now delivered to the expression box. They are placed on the perforated tray A compression plate is then placed over the fibrin clots, and then a weighted cover is placed over the compression plate. This weighted cover is allowed to sit for approximately 5 minutes while the serum is being compressed out of the material. When the compression plate is removed, we find these 3 beautifully compressed fibrin membranes. In this video, we see a single fibrin membrane holding multiple heavy surgical instruments. This really speaks to the durability and strength of the PRF membrane. In fact, it can be sutured and it will not tear. There are times when we may prefer to have socket plugs rather than membranes. Here we demonstrate the fabrication of a socket plug. We will place the fibrin clot into the Delrin cylinder and then we will compress these clots with the piston assembly. The piston assembly is inverted and placed into the Delrin cylinder and compressed until it is even with the top. In this way, we fabricate very consistent plugs that are suitable for extraction sites. Here, the fabricated fibrin plugs are demonstrated. There may be times, however, that we need to employ a biomaterial. We can use this serum that is collected at the bottom of the collection tray to hydrate the bone graft material. In this way, we make the bone graft more bioactive and we improve the handling characteristics. Note the adhesion of the bone graft material to the spatula. PRF is also an excellent carrier for particulate bone material. It can be used in one of three ways. We can mince it and mix it with a bone graft material. We can place a bolus of graft material surrounded by a PRF membrane, or we can mix the particulate within the PRF matrix before it coagulates to make a bone patty. Leukocyte-containing platelet-rich fibrin. Growth factor technology available from the scientific research team dedicated to biomimetic implant technology, Intralock International.